Hello everyone, GCE Connect. I welcome you all for this particular lecture. So again in this particular lecture I'll be continuing with the welded connection, that is the tension members, design of tension members. So again in previous lecture also I solved one problem, so where the single angle connected to the gusset plate. Again this one more problem, that is again the single angle connected to the gusset plate. Here the problem given as determine the design strength of a single angle tension member consists of single angle 80 by 50 by 8 mm. The shorter leg of the angle is connected to the gusset plate by 5 mm weld as shown in the figure. Cross sectional area for this angle is 978. So here this cross section area is given and this is the figure given. So this is the figure given. Let me show this one. So this is the figure. So this is the gusset plate. This one is the gusset plate. This is the gusset plate and this is a single angle. So this leg is 80 mm and this leg is 50 mm, and here the weld is done, here the weld is done. So this is the figure given. Again this upper side weld is having a 110 mm long and this weld is having 230 mm long. If I draw longitudinal section of this one, it will be like this. If you draw this one, here you will get a thickness of angle section. So gusset plate. So this is the thickness and the weld here is this one 110 mark and this one is 230 mm. This is 230, this 230 millimeter, this is 110 millimeter. Okay, then this is the centroid of the angle. Let us go take this one. This will be CXX and this will be EXX. So this CXX and EXX you have to get from the steel table. So unequal angle I will show you here. This one is 80 by 50 by, here it is 80 by 50 by 8 mm, 80 by 50 by 8 mm, 80 by 50 by 8 mm. So what is the area given here? This is a area column 9.78 and also the CXX, this column. So the first column is dimension and the size A and B, and second column is the thickness, third is the sectional area, then weight per meter, center of gravity, distance of extreme fiber, that is EXX and EYY. So for 80 by 50 by 8 mm, so here the CXX is a 26.4. just write on here CXX, here this one. Sorry, CXX will be 27.3 and EXX will be 50. Exx will be 52. Actually this is a longer leg connected to the gusset plate for that one first, but here they have mentioned shorter leg is connected to the gusset plate. See, this is the longer leg, this is the shorter leg, this one. Here this is a longer leg and this is a shorter leg. So here we have to take CYY and EYY because this leg is connected. So what is CYY here? CYY will be 12.4 just to cancel it. This is for longer leg. We have to take CYY 12.4 and EYY 37.6. I hope you understood this one. So here written CYY and EYY. Here in this figure, this one. So this longer leg, this is longer leg and this is shorter leg. Shorter leg is connected to the gusset plate, so we have to take this distance CYY and EYY. CYY and EYY. Okay. Then first one, we have to calculate the tensile strength of section from the yield consideration. Tensile strength of section from yield consideration, that is TDZ. TDZ equal to AG FY divided by gamma MO. Then substitute from the steel table. AG will be, but no need to refer steel table here because the directly not area is given here 978 millimeters square. Then Fy is 250 Newton per millimeter square. Then substitute here 978 250 divided by 1.1, you will get 222.27 kilonewton. This is TDZ. This is TDZ. Okay, so here area is given, so no need to refer steel table. Even you can cross verify this one. The angle size is here given 80 by 50 by 8, 9.78 is, so 978 millimeters square it is given. If not given, you refer it and take the area. Okay, so here the area is given, take directly and calculate. This is TDZ. So next we have to calculate second one, net section rupture. Net section rupture. So net section rupture here, TDN formula we know. Again refer code for this. So this is the TDN. Can refer page 33 IS 800 2007. So page 33 IS 800 2007, if you refer, you will be getting this formula for single angle 0.9 FU ANC divided by gamma ml plus beta AZO Fy divided by gamma MO. Okay, so here Fu will be for a plate 410 Newton per millimeter square, Fy is 250 Newton per millimeter square, then gamma MO will be 1.1, then gamma ML will be 1.25, and ANC will be the net connected leg area. So this leg area, this leg is connected, means 50 mm, that is shorter leg is connected to the gusset plate, the connected leg area, and this is a outstanding leg area. This is outstanding leg, this is connected leg, this one is connected leg, and this is outstanding or unconnected. This is outstanding. Okay, so here ANC is a connected leg area, so we get connected leg area, that is L minus T by 2 into thickness. L is 50 minus thickness is 8 by 2 into 8, we get 368 millimeter square. Similarly, gross area, that is outstanding leg area, that is L1 minus T by 2 into T. Here no need to deduct the bolt hole because we are not providing any bolts here, we are providing a weld, so directly thickness only you have to deduct half of that thickness. So here 80 minus 8 by 2 into 8, you will get 608 millimeter square. So how this formula comes, I explained earlier this one, so once again I will explain this one. Suppose this is angle if we take this corner, okay, just draw like this and draw like this corner. So this leg length has get overlapped on this leg, so some portion of this leg has get overlapped on this leg, and some portion of this leg has overlapped on this one. So just you draw this corner like this, then you mark this one, this as a L, and this is L1. Okay, and what is this thickness? This thickness is how much? This is T, and this also T. Okay, so if I want to get the area of this leg, how I can get? L minus T into T, means up to here I get L minus T, this area, this one, this area I get L minus T into T, then you have to add this much area, this is triangle for this leg, plus how will you get this area? This triangular portion, half base is T, then thickness, to get here LT minus T square plus half T square, then minus T square plus half T square, you will get LT minus half T square. But you get, take T out, L minus T by 2 into T. So likewise this also same you will get. So this is the formula you have to use. Just this is for your information, this one. then the value of beta will be 1.4 minus 0.076 value of beta, this formula. 1.4 minus 0.076 W by T, then Fy by Fu into Ps by Lc. So this is the formula. So again you refer code. So W is the outstanding leg width 80 mm, T is 8 mm thickness of the angle section, then Bs is again is equal to W, that is for welded connection, then Lc will be average length you need to take, that is 230 plus 110, average length of weld you have to take, so 170 mm. This is the average you have to take average length. Then calculate beta. When you substitute all values, you will be getting beta 1.182. This should be or equal to 0.7 as per the code. So please refer a code. You will get the equation for beta, then get the value of beta. Then substituting the value of beta in the above equation TDN, you will be getting TDN as 0.9 into 410 into 368 divided by 1.25 plus 1.182 into 608 into 250 divided by 1.10. Then when you calculate this one, TDN comes to be 271.96 kilonewton. This value. Okay. Calculate this TDN. Okay. So next is we have to calculate TDB. Third one, block shear strength. Block shear strength, that is TDB. So you know the formula for block shear. Again you refer a code, that is page 33 IS 800 2007. Then TDB1 is equal to AVZ Fy divided by root 3 gamma mu plus 0.9 ATN Fu divided by gamma ml. This is TDB1, and TDB2 will be 0.9 AVN Fu divided by gamma ml plus ATZ Fy divided by gamma mu. Okay, you have to calculate these two, and the least of these two will be TDB. Then take or providing 10 mm gusset plate. Okay, so here gusset plate thickness is assuming, then AVZ is equal to AVN in case of a welded connection. This will be LV into thickness. So LV here we to take the LV length is given, that is 110 plus 230, average length to be taken here, divided by 2 into 10 you have to take. So you will be getting a 110 plus 230 divided by 2 into 10, 1700 average shear length LV to be taken, then AVN or ATZ is equal to ATN, that is tension area. This one, this is shear area. You have to take the average length, and this one is the tension area. That is 80 into 10, 50 into 10, that is 50 into 10, 50 into 10, that is 500. Then calculate TDB1 and TDB2. So it comes out to be just calculate 1700 into 250 divided by root 3 into 1.1, that is you get 223 here, 223.06 into 10 raised to 3 plus 0.9 into 500 into 410 into 1.25, (147.6) into 10 raised to 3, you get 223 plus 147.6, so you will get 370.6 kilonewton here, this TDB1. And TDB2 will be 0.9 into 1700 into 410 divided by 1.25, 501.84 into 10 raised to 3 plus 500 into 250 divided by 1.1, 113.63 into 10 raised to 3, it comes out to be 501.84 plus 113.63, 615.47 kilonewton. Okay, so just check these answers. So the least of these two will be the TDB. Therefore TDB will be least of TDB1 and TDB2. Therefore TDB will be 370.6 kilonewton. Therefore design strength will be the least of TDZ, TDN and TDB. So you will get 222.27 kilonewton. Finally 222.27 kilonewton. Okay, so this is the way to calculate the welded connection problems. Okay, so please practice these kind of problems and understand the problems. So here you take one example, so that is you take this example as a homework. So a single angle 150 by 90 by 10 mm is used as a tension member. So it is connected to 12 mm thick gusset plate at ends with 5 of 16 mm dia bolts. Bolts are pitched at 50 mm. Find the net area if longer leg is connected to the gusset plate and if shorter leg is connected to the gusset plate. So take this problem as a assignment and solve it. Thank you.